So speaking of question 5, the first we need to do is to find lambda. And from the question we can get the condition that the probability that in 2 minutes at least one customer arrives equals to 0.3. So we can change this condition to the formula above. So we can get the formula as this: the probability that in 2 minutes at least one customer arrives equals to 0.3. And then we can change this formula in another form. We can get the opposite condition. Since the question says that at least one customer, so its opposite condition is that no customer arrives. So the probability that in 2 minutes no customer arrives equals to y minus the 0.3, which is 0.7. So now we can get the new condition that in 2 minutes the probability that no customer arrives equals to 0.7. And then we can take this formula into the take this condition into the formula into this formula, and then we can calculate that, then get the lambda equals to 0.178, and that's the first answer of this question. So after that, after we get the lambda, we can update our formula. So we can take the lambda to 0.178, and then the new formula will be this. So secondly, we need to find the probability that in 3 minutes no customer comes. So also we can change this condition to our formula, which means the probability that in 3 minutes that no customer comes, and then we can take this, we can get the k and get the t. So we can take this into the formula. So after calculation, we can get the second question's answer is 0.586. So the third question is same as the second question. The only difference is that at least 2 customers will arrive. So we can also imagine the opposite condition, which is there are only one customer, or there will be no customer. So we can change this formula. We can change that the probability in 10 minutes there will be at least 2 customers into y minus in 10 minutes no customer will arrive, and minus in 10 minutes there will be only one customer. So for these two formula, we can get the data k, which is 0 and 1, and the time is 10. So take this into this formula, and we can then, after calculation, we can get that in 10 minutes at least 2 customers will arrive. The probability will be 0.531. So at last, we need to find the probability that in 1 minute exactly one customer will arrive. So since the time and the k is clear, so we don't need to change this condition into opposite sides. So in this question, the time is 1 and also the k is 1, so we can write the probability like this. So in 1 minute there will be only one customer arrive. So similarly, we take this t and k into this formula as t equals 1 and k equals 1, 2. And then we can calculate the probability that in 1 minute there will be one customer arrived